already discussed one-to-one and onto functions. Let's discuss some diagram based on it. First diagram, here A maps to 3, B maps to 4, C maps to 1. It is one-to-one. As for every domain, there is just one image, but it's not onto as 2 is free. In case of onto, for every codomain, there should be some pre-image. As 2 is free, so it is not onto, but it's one-to-one. Next option B, here A maps to 2, B maps to 1, C maps to 3, D maps to 2. As A and D both maps to 2, so it is not one-to-one. A, D are different, but they are mapped to same element, it's 2. So they are not one-to-one, but it's onto. As all elements of codomain are image of some domain, like 1, 2, 3 all are image, so it is onto but not one-to-one, as A, D both maps to 2. Next option C, here A maps to 4, B maps to 1, C maps to 3, D maps to 2. It is one-to-one. Also it is onto, as all codomain are image. For one-to-one, cardinality of A can be less than or equals to cardinality of B. For onto, cardinality of A can be greater than equals to cardinality of B. For both one-to-one and onto, cardinality of A should be equals to cardinality of B. If both set contains same element, then it can be both one-to-one and onto. In option A, it is one-to-one but not onto. Here, A length is 3, B length is 4. 3 is less than 4. Option B, it is onto but not one-to-one. Here, length of set A is 4, length of set B is 3. 4 is greater than 3. Option C, it is both one-to-one and onto. Both cardinality are 4. Next option D, here A maps to 2, B maps to 1, C maps to 2. As both A, C maps to 2, so it is not one-to-one. Next D maps to 3, and here 4 is free. 4 is not image of any domain, so you can say it is not one-to-one and not onto. Not one-to-one, as both A and C maps to 2, and it is not onto, as 4 is free. Next option A, here A maps to 2 and 4. As A maps to 2 elements, so it is not a function. In case of function, one domain can map only one codomain. Here A maps to 2 and 4. For A, there are 2 images, so it is not a function. One element of set B can be image of 2 domain, but one element of set A cannot map to 2 images. Okay, so this is not a function, so there is no question of one-to-one and onto. Next I will discuss bijection. First definition of bijection: a function f is a one-to-one correspondence or a bijection if it is both one-to-one and onto. We will say that such a function is bijective. If it is both one-to-one and onto, then we can say it is one-to-one correspondence or bijective. Bijection function possible if length of A equals to length of B. If both cardinality are same, then only bijection is possible. If A cardinality equals to B cardinality equals to n, then number of bijection function possible equals to n factorial. I already discussed number of one-to-one functions and number of onto functions in previous lecture. Here number of bijection function possible is n factorial. Let's see one example. Example 14. Let f be a function from a, b, c, d to 1, 2, 3, 4 with f of a equals to 4, f of b equals to 2, f of c equals to 1 and f of d equals to 3. Each f is bijection. Let's check it. Here f of a equals to 4, then f of b equals to 2, f of c equals to 1, f of d equals to 3. All maps to different elements, so it is one-to-one. Also all elements of set B are image of some element. 1, 2, 3, 4 all are image, so it's also onto, as it is both one-to-one and onto, hence F is a bijection. Or you can say it's a one-to-one correspondence. Suppose that F is a function from set A to itself. If A is finite, then F is a one-to-one if and only if it is onto. Suppose set A contain 1, 2, 3, and we want to find a function from set A to itself. Means f of 1 equals to 1, f of 2 equals to 2, and f of 3 equals to 3. We can say this function is both one-to-one and onto. Let A be a set. The identity function of A is the function I of A. A maps to A where I A of x equals to x. Means I A of 1 will be 1. I A of 2 will be 2. Suppose set A contain 1 to 10, then identity of 1 will be 1, identity of 2 will be 2, identity of 7 will be 7, identity of 10 will be 10. So it's for all x belongs to A. The identity function I of A is the function that assigns each element to itself. So f of x equals to x. We are assigning x to x. The identity function is both one-to-one and onto, hence it is bijection. Or you can say the identity function is one-to-one correspondence. In today's lecture, I discussed different diagrams based on one-to-one and onto functions, bijection functions, and identity functions. In next lecture, I will discuss inverse function and composition. If today's lecture is helpful for you, please like, share, and subscribe. Thank you.